Question 4.1. Part A for 8 marks. Consider the function f of x equals to e to the power of mod x. Draw the function as a graph and show at least 2 points in the graph. For the first 2 points, first take the case where x equals 0. Then f of x is equal to e to the 0. Now any number to the power of 0 is 1. First point that we have on the graph is 0, 1. For x greater than 0, the graphs will follow a standard growth function. In particular then, when x equals 1, e to the power of 1 equals e, and the value of e is approximately 2.71828. And so like pi, which is approximately 22 over 7 or 3.14159, e is a number that you should commit to memory. E is approximately 2.71828. A second point on the graph is 1 comma e, or 1 comma approximately 2.71828. It's approximate since e is an irrational number. Now what happens when h gets a negative? Typically the graph of e to the x would tail off approaching 0 as x tends to infinity. However, because x is inside the modulus of the absolute value, the sign of minus x is reversed to be x. The graph makes a mirror of the positive case, and it will then go through minus 1 to the e on the same logic, and it will go up and on to infinity. Part B for 2 marks. Write down a value for x for which f of x is not differentiable. Every absolute value function has a point which is not differentiable. That's at the point at which the expression inside the modulus is equal to 0. If you look at the graph, it forms a cusp at x equals 0. This is because the limit as x tends to 0 increasing from the negative side is negative, and the derivative of x as x tends to 0 decreasing from the positive side is positive. The two derivatives are not equal, so the function is not differential at x equals 0.